Okay, so get this. Imagine AI
Yeah.
that doesn't just, see what's happening in a video, but it actually understands it. Like really grasps the plot of a movie or the emotions, behind a reaction, even predicting what might happen next.
Right.
Sounds pretty sci-fi, right?
It does.
Well, today's deep dive is all about how that sci-fi is becoming reality.
Yeah, it really is a fascinating leap forward.
Yeah.
We're moving beyond AI just recognizing objects in a video, like, oh, that's a cat, that's a car, that's a tree,
Right?
to a place where AI can understand what those objects are doing, how they're interacting, and what that all means in the bigger picture of the video.
Yeah. And to really, dig into all of this, we're looking at some cutting-edge research from Meta and Stanford, just published last month.
Yeah.
It focuses on large multimodal models, LMMs for short.
Right.
Specifically designed for this whole video understanding thing.
This is where things get really interesting.
Okay.
They've developed a family of these models called Apollo.
Okay.
And trust me, the name is quite apt. These models are achieving some really impressive results, especially when you consider their efficiency.
Efficiency, huh?
Yeah.
So it's not just about throwing more computing power at the problem.
Frankly, one of the biggest hurdles in video understanding has always been the just massive amount of data and the processing power required.
Right.
It's like trying to understand a book by analyzing every single letter rather than reading the words and sentences.
Okay, I see the challenge.
Yeah.
But how does Apollo kind of address this?
Well, for starters, they've discovered this principle of scaling consistency.
Okay.
So imagine you're an architect designing a skyscraper.
Right.
You wouldn't build the entire skyscraper just to test if the foundation is strong enough.
No, you'd start with a smaller model, see if it works, and then scale up.
Exactly.
Right.
And that's precisely what they've done with Apollo.
Okay.
They found that design choices that they make on smaller models, which are obviously less computationally expensive to train and work with,
Right.
those choices can reliably translate to the larger models.
So that's really interesting.
Yeah. So this means they can test out new ideas and make improvements much faster, which is a huge game changer for research in this field.
So they're being smart about how they, design and train these models.
Absolutely.
Which is leading to better results with, less computational heavy lifting.
Yeah.
So kind of like a brain, right? Like a small, efficient brain can often outperform a larger, less organized one.
That's a great analogy.
Yeah.
And this is actually one of the areas where Apollo's design really shines in how it handles video sampling and encoding.
Okay, break that down for me.
Sure.
What exactly is sampling in this context?
So think about it like this. You're watching a movie,
Okay.
but you can only see a few frames per second. Would you be able to follow the story?
Probably not, no.
No, probably not.
Yeah.
And it's the same for AI trying to understand a video.
Right.
It needs to see enough frames to get a sense of how the events are unfolding.
So sampling is all about picking which frames the AI gets to see.
Exactly. And traditionally, researchers have used this method called uniform sampling,
Okay.
which essentially picks frames that are evenly spaced throughout the video.
Okay.
But the creators of Apollo decided to test a different approach called FPS sampling,
Okay.
which grabs frames at a consistent frame rate like how a movie is filmed.
Oh, okay.
Yeah.
I would have thought uniform sampling would be better, just more representative of the whole video.
Yeah, it seems intuitive, but their research actually shows that this FPS sampling consistently outperforms uniform sampling.
Really?
And it's likely because it preserves that temporal relationship between the frames.
So it's like the difference between flipping through a flip book smoothly
Yes.
versus skipping pages randomly.
Yeah.
You lose the flow.
Yeah, you lose the flow, you lose the story.
Yeah, exactly.
And then when it comes to encoding the video, which is essentially turning that visual information into a format that the AI model can actually understand.
Right.
Apollo uses this powerful combination of a really cutting-edge image encoder called SIGLIP SO400M, and then also a specialized video encoder called Intern Video 2. So this kind of gives it the best of both worlds, detailed spatial understanding from the image encoder and accurate temporal representation from the video encoder.
Okay, so we've got the video broken down into all these encoded pieces. But how does the model actually integrate that visual information with text?
Right.
How does it understand the meaning of what it's seeing, in the context of language?
Right. That's where things get even more interesting. We need to kind of delve into the world of tokens.
Tokens, remind me what those are again?
So tokens are like the fundamental building blocks of information that these LMMs process.
Okay.
Think of them like the words in a sentence.
Right.
But the challenge here is that these LMMs, they're primarily designed to process text tokens.
Right.
So how do you effectively weave in the visual tokens from a video?
That's a tricky problem.
It is. It's like trying to understand a story where someone's constantly switching between English and emojis.
Perfect analogy.
Yeah.
And so the researchers behind Apollo, they came up with a surprisingly simple solution.
Okay.
They just add timestamps before each video clip.
Mm-hmm.
So essentially they're telling the model, hey, this clip you're about to see is from, minute 0.35 to 0.42.
Oh, so it's like giving chapter headings in a book.
Exactly.
Yeah.
It helps the model understand where each piece of the story fits into that larger timeline.
I'm starting to see why you're so excited about this research.
Yeah.
They're really tackling these fundamental challenges head on.
Yeah, absolutely. And it's not just about, coming up with clever solutions.
Right.
It's about making sure that those solutions actually work.
Mm-hmm.
Which brings us to the topic of benchmarking.
Benchmarking. So how do they know if Apollo is actually learning and improving?
Well, that's where things get a little controversial.
Oh.
They discovered that many of the existing video benchmarks...
are in many ways not really up to snuff.
What do you mean?
A lot of them are redundant, they're incredibly computationally expensive, and often they don't truly test a model's understanding of video. You could get a good score on some of these benchmarks just by analyzing a single frame.
Oh, wow.
Yeah, so they're not really challenging the models to truly understand the video part of the equation.
Right, they're not getting the full picture.
Exactly, and that's why they actually created a new benchmark called Apollo Bench,
Okay.
which is designed specifically to evaluate video-centric tasks,
Mm-hmm.
ensuring that we're truly measuring progress in video understanding.
Okay.
It's much more efficient, and it really raises the bar for the field.
So it's a more accurate test.
Yeah,
Interesting.
but that's not all.
There's more.
They've also made some really groundbreaking discoveries about how to train these models effectively.
Okay, now you've really got my attention.
Yeah.
Let's dive into that in part 2.
So you see, training a large multimodal model like Apollo, it's not as simple as just like, throwing a bunch of videos at it and hoping for the best.
Right.
It's a much more nuanced process, kind of like training for a marathon.
Yeah, you can't just run 26 miles on day 1, right?
Exactly. You got to build up gradually.
Right.
And Apollo's training involves this really carefully designed multi-stage approach.
Okay.
Think of it like a school curriculum.
Mm-hmm.
You start with the basics and you gradually progress to more complex concepts.
Okay, so walk me through this AI curriculum. What are the different stages?
Sure. So in the first stage, they focus on training what they call the connector.
Okay.
This is the part of the model that kind of bridges the gap between the visual information from the encoders
Right.
and then the language model.
Okay.
And importantly, they actually keep the language model itself and the vision encoders frozen during this initial stage.
So it's like getting the translator fluent
Exactly.
before you give them the full dictionary.
Exactly. You got it. Then in the second stage, they unfreeze the vision encoder and they start training it on video data.
Mm-hmm.
This allows it to kind of fine-tune its understanding of motion and these temporal relationships.
Right.
The things that make video video.
Right, because a still image only tells part of the story.
Exactly.
Yeah.
And then finally, in the third stage,
Okay.
they bring in the big guns, the language model,
Mm-hmm.
and they start training it on this really diverse mix of text image, multi-image, and video data.
Wow.
Yeah, so by this stage, the model has this really solid foundation in both visual and language understanding,
Right.
and it's ready to kind of tackle those complexities of video comprehension.
So by the end, it's had this chance to learn from all these different types of data, gradually building up its understanding, just like a human student.
Precisely, and their research actually shows that this progressive training approach leads to significantly better performance than just training the whole model on everything at once. It's all about building that solid foundation and then progressively increasing the complexity.
It makes sense when you think about how we learn. We don't start with advanced calculus, right? We start with like basic arithmetic,
Exactly.
and we build from there.
Yep, seems like AI is no different.
Yeah, fascinating.
And speaking of building up, they made another really interesting discovery during this whole training process.
Okay.
They found that fine-tuning the video encoder on only video data
Okay.
rather than a mix of image and video data actually led to better results.
That's surprising. I would have thought more data is always better.
You'd think so, right?
Yeah.
But it seems that training the video encoder on too much image data can actually muddy the waters a bit.
Interesting.
Yeah, by focusing solely on video, it can really hone its skills in understanding those temporal aspects, the motion, the flow, the change over time that are so crucial to video comprehension.
So it's like a chef specializing in French cuisine.
Mm-hmm.
They don't need to know how to make sushi to perfect their souffle.
I love that analogy. It's about focusing on what really matters most for that specific part of the model.
Right.
And then when it comes to training these models, the data itself is just as important as that whole training process.
Okay.
They did this really deep dive into the data composition, the mix of text and images and videos that they fed the model.
Yeah, their data diet. I'm really curious to hear what they found.
Yeah.
What's the recipe for success when it comes to feeding an AI?
Well, one of the biggest takeaways was that including a moderate amount of text data in that training mix is absolutely crucial.
Okay.
Around 10 to 14% seems to be that sweet spot.
Wait, why is text so important for a model that's supposed to understand videos?
Right. It might seem a little counterintuitive.
It does, yeah.
But remember, these are language models at their core.
Right.
They need a good dose of text to maintain their language processing skills
Okay.
and avoid this phenomenon called catastrophic forgetting.
Catastrophic forgetting, that sounds pretty ominous.
Yeah, it's not as dramatic as it sounds. It essentially means that the model can start to lose its grasp of language as it learns more about vision.
Oh, so it's like if you only spoke Spanish for a year, you might start to forget some of your English.
Exactly. Use it or lose it.
Right.
So that text data helps keep the language part of the model sharp.
Okay.
Even while it's learning to understand the videos.
So it's like a mental workout
Exactly.
to keep everything in shape.
Yeah, and they actually found that if you include too much text or not enough performance actually suffers.
Interesting.
It's all about finding that balance, that well-balanced meal for the AI.
Okay, so what about the rest of the data composition, the images and videos? What's the ideal ratio there?
Well, after experimenting with different mixes, they found that having a slightly video-heavy composition worked best for the remaining portion.
Okay.
This likely stems from the fact that there are already so many high-quality image data sets out there that the model can learn from.
Mm-hmm.
So by tilting the scales towards video, they can ensure the model gets that strong foundation in understanding motion and temporal relationships.
So video really is king in this case.
It seems so.
Yeah.
And it makes sense. Video is inherently more complex than still images.
Right.
So it stands to reason that the model would need more exposure to it to really master that whole video understanding.
This is all fascinating stuff,
Yeah.
really granular details about this training process and the data composition that can have this huge impact on performance.
Yeah,
It's amazing how much thought goes into training these models.
it really is.
It's like a science and an art form all rolled into one.
Absolutely. And these are just a few highlights from the research.
Right.
The paper itself goes into even greater depth
I bet.
on things like hyperparameter tuning and data set selection.
I can only imagine the rabbit holes you've gone down
Oh, yeah.
in this paper.
Many, many rabbit holes.
But before we go full AI research mode here,
Right.
I want to kind of circle back to the bigger picture here. You know, we've talked about the challenges, the design choices, the training process. But what does all this mean?
Right.
Why should our listener care about this research?
That's the key question, isn't it? And I think to answer it, we need to step back from those technical intricacies
Okay.
and really consider the potential impact of all of this on the world around us.
Right.
It's about looking beyond those algorithms and envisioning a future that's shaped by AI that truly understands video.
So what does this mean for someone who's not an AI researcher, but is just curious about the future of technology?
Yeah.
Paint a picture for us. What could this technology enable?
So for one thing, it means we're getting closer to a world where AI can understand and interact with the visual world in ways that, were once considered the realm of science fiction.
Right.
Imagine AI systems that can not only analyze videos, but also generate them.
Wait, are you talking about AI that can actually make videos?
Yeah.
Like write a script, direct the actors, edit it all together?
Exactly.
That sounds incredible.
It really does.
And maybe it's a little bit intimidating.
It's definitely bold vision, and we're not quite there yet.
Right.
But research on video-LMMs like Apollo is laying the foundation for that kind of creative AI.
Okay.
Imagine a world where AI can help us tell stories, share information, and express ourselves in entirely new ways through video.
Okay, now that's a future I can get excited about.
Yeah.
But beyond the creative applications, what about more practical uses? Where could this technology make a real difference in our lives?
Think about fields like education, healthcare, security. Virtually every aspect of our lives involves video in some way.
That's true.
And imagine how much more efficient, effective, and personalized those experiences could be if AI could truly understand the content of those videos.
Give us some concrete examples.
Sure. So in education, AI could analyze students' engagement with video lessons, identify areas where they might be struggling, and tailor the content to their individual needs.
Oh, wow.
Imagine a world where every student has a personalized AI tutor.
It would revolutionize how we learn.
Yeah.
It would be like having a private tutor for every student available 24/7.
Exactly. And the applications go far beyond education. In healthcare, AI could assist doctors in diagnosing conditions by analyzing medical imaging videos, identifying subtle patterns that might be missed by the human eye. It could even help predict potential health issues before they become serious, enabling early intervention and potentially saving lives.
That's amazing.
And in a world where, security is becoming increasingly important, AI could be used to analyze surveillance footage, identifying potential threats and helping to prevent crimes.
It feels like the possibilities are kind of endless.
They really are, and they all stem from this fundamental ability to understand video.
It's exciting and a little bit daunting all at the same time.
Yeah.
But isn't that always the case with cutting-edge technology?
It is.
It has the power to change the world for better or for worse, depending on how we choose to use it.
That's a crucial point. And it brings us to the ethical considerations surrounding this technology.
Yeah, it's true with any powerful technology. You always have those questions. What could go wrong? How do we prevent misuse?
Absolutely. With great power comes great responsibility, as they say. And when it comes to AI video understanding, that responsibility really lies with all of us. The researchers developing the technology, the policymakers setting the rules, and society as a whole, deciding how we want to use it.
So it's not just a technical challenge then. It's a societal one too.
It is.
We need to figure out how to harness the power of this technology, but also ensure that it's used ethically and responsibly.
Exactly. And one of the keys to responsible AI development, I think, is transparency. We need to understand how these models work, what data they're trained on, and, what biases they might have. If we don't know how the AI is making decisions, we can't really trust its judgment.
It's like giving someone a superpowered telescope, right?
Yeah.
They could use it to explore the stars or to spy on their neighbors.
Exactly.
We need to make sure we're using this technology to look up, not to pry.
That's a perfect analogy. And then another crucial aspect is privacy. Video data can be incredibly personal. So we need to be extremely careful about how it's collected, stored, and used. Consent is paramount. And there need to be really strong safeguards in place to prevent misuse.
Yeah, because once something's captured on video, it can be really hard to control how it's used. And with AI getting better and better at analyzing and manipulating video, the potential for harm just keeps increasing.
That's why it's so important to have these conversations now. While the technology is still developing, we need to kind of anticipate those potential risks and put safeguards in place to mitigate them. It's about being proactive, not reactive.
So it's a balancing act.
Yeah, it is.
We need to embrace the incredible potential, but also be mindful of the risks.
Yeah. Find that sweet spot where innovation and responsibility intersect.
Like that.
Yeah, and that's where the listener comes in.
Okay.
We all have a role to play in shaping the future of AI. We need to stay informed, engage in these conversations, and demand that this technology is developed and used in a way that benefits everyone.
It's a powerful reminder that technology is never really neutral. It's a reflection of the people who create it. And the society that it's a part of.
Absolutely.
And it's up to us to ensure that it reflects our values.
Our values of fairness, privacy, responsibility.
This has been an incredible deep dive.
It has.
It's really opened my eyes to the possibilities and the complexities of this whole AI video understanding thing.
Me too. It feels like we've gone from watching a silent film to experiencing a full-blown IMAX 3D movie.
I like that.
And I can't wait to see what the next scene holds.
Me too. And for our listeners, we encourage you to check out the links in the show notes. To learn more about Apollo and the research that we've been talking about today, it's a fascinating field and one that's sure to have a big impact on our lives in the years to come.
The future of video understanding is unfolding before our eyes, and it's up to all of us to shape that future responsibly.
This has been an incredible journey. Thanks for joining us on this deep dive. Until next time, keep exploring, keep learning, and keep diving deep.